Assalamualaikum. Hi everyone. So this will be the third video for chapter 1, reaction kinetics. We are still in the subtopic 1.1 reaction kinetic, and at the end of this lesson, you should be able to determine the order of reaction involving single reactant using initial rate method. Now, let's take a look on what we have today. So before we go specifically on our topic today, let's take a look on the methods to determine the order of reaction. So in my previous video, we already talked about how to write down your rate law, and then inside the rate law, we have order of reaction. So in this video, we're going to look on how to determine the order of reaction. So to determine the order of reaction, actually we have three methods. The first one is initial rate method, second linear graph method, and the third one is half-life method. But for this lesson, we're going to focus only on the initial rate method, the first method here. Okay, so let's start. Initial rate method. So what does it mean by initial rate method? This method is used when the initial rates of reaction and initial concentrations of the reactants are given. So, as we have discussed in the previous video, I have mentioned that the rate law does not affected by the balanced chemical equation. So, let's say I give you a general equation here. So, 2A plus B to produce C, and given the rate law as rate equals to K, concentration of A, concentration of B to the power of 2. Let's say this is the rate law that we have. Okay, so what you see here is concentration of A is to the power of 1 and concentration of B is to the power of 2. Okay, how do we get this number? We will get this number by experiment. Okay, and just to refresh back your memory, this number is what we call as the order of reaction. So, for us to get this order of reaction by using the initial rate method, the information that we will have is we're going to have the rate, the initial rate, the first rate of the reaction, and the initial concentrations of our reactants A and B. And we will vary the concentration so that we will have a few rates. And we can compare these rates and concentration for us to get what is the order of reaction. So now, let's take a look on the example. So in this video, I will give you two examples, but the way of calculating the answers is the same. So now let's take a look on example 1. So example 1, the experimental data obtained at 27 degrees Celsius for the reaction is shown below. So CH3, CH, Cl, CH3 plus NaOH to produce CH3, CHOH, CH3 and NaCl. And then given here, inside a table, okay, we have three different experiments but using the same reactant, because we want to know the rate of the reaction of the same reactions by using a different concentration. Different concentration will give us different rate of reaction. So if you look here, each reactions will give us a different rate of reaction. So by using this different rate of reaction and also varying the concentration, we can find what is the order of reaction with respect to each of the concentration. So now let's take a look on how the question will be. So this is the set of questions that usually asked in exam. So the first one, determine the order of reaction with respect to CH3CH, Cl, CH3, and NaOH. So in your notes, I mistakenly put as with respect to A and B. So please help me to change that. Okay, next question B. Write the rate law for the reaction. C. Determine the overall order of reaction. And D. Determine the rate constant for the reaction. So if you see here, it's actually a flow of question. Okay, to answer question D, you need to have the information on question B, and to have B, you need to first find the order of reaction with respect with each concentration of the reactants. Okay, so how do we tackle this question? So now let's take a look on how to solve the question. Okay, so let's start with question A. How are we going to answer this question? So the question asks, determine the order of reaction with respect to each concentrations of the reactant. So like I said before, we're going to compare between two rates of reactions and also two concentrations. Okay, that's why for your data, you need to have at least 3 different number of experiments to get 3 different rates, so that we can compare and find the order of reaction. Okay, so how are we going to start the question, to answer this question? So the first one, we're going to start by writing down the rate law first. So let's start with question A. So our rate law, so rate equals to K, so our reactant concentration CH3, CH, Cl, CH3, and here in our rate law, we need to have the order of reaction. So since we are trying to find the order of reaction, so we will put here the some coefficient. So I put it as M. If you want to put anything else like X or Y, is also accepted. Okay, so and then the other one, our reactant, NaOH. So I put it as N. So if let's say you have more than 2 reactants, you have 3 reactants. So when writing down the general rate equation, the general rate law here, you need to have the third reactants as well. Okay, so for this question, I only have 2, so I write 2. So the order of reaction is to the power of M and to the power of N. Okay, I want to start by finding what is the value of M. How I'm going to find the value of M? So let's take a look back at the information here. To find the value of M, I need to constant the concentration of sodium hydroxide. So choose 2 experiments that have the same concentration of sodium hydroxide. So which is this one, these 2 correspond to experiment 1 and experiment 2. Okay, so you will write down, we will compare between experiment 3 and experiment 1. But before that, let me show you what are we comparing. Okay, so I have written here the rate law for each experiment, experiment 1, experiment 2, and experiment 3. So the one that we are comparing is actually these equations. Okay, so like I said before, for the first one, we want to find what is the value of M. So we're going to choose, we're going to choose the experiment that shows the concentration of sodium hydroxide, the second reactants, as constant. Okay, so that we can straight away find what is the value of M. Okay, now, so let's take a look on what we will do. So I will compare experiment 3 with experiment 1. So you will write it down like this. So now, write back all the information we have here. So for experiment 3, it's 9, the rate is 9 times 10 to the power of negative 3 equals to K 0.45 to the power of m and 0.25 to the power of n. And then we're going to write down for experiment 1. So 3 times 10 to the power of negative 3, and then its rate K 0.15 to the power of m over 0.25 to the power of n. So we're going to write this down first. Okay, the most important part is this part here. Okay, now, so from here, we're going to solve the question. So if you look here, we can cancel out the same term. So that's why it is important to have at least one concentration, that one reactant that has the same concentration, so we can cancel it out. So here I can cancel everything here, and I can also cancel the value of K, because by right K is constant, rate constant, so the value should be the same. So from here we can proceed and calculate the value here. Okay, now, so if you look here, I divide experiment 3 by experiment 1. Can I do the other way around, 1 over 3? Yes, you can do so, but it will be easier for the one on top that has a bigger value, okay, to make the calculation a bit easier. So let's continue with the calculation. So from here, okay, you will get 3 equals to 3 to the power of m. Okay, what you can see here is this number, the base number here, is the same, 3. Okay, so you will put it like this. So 3 to the power of 1 equals to 3 to the power of m. For us to get what is the value of m, so you need to make the base number here the same. So you can conclude that the value of m equals to 1. So what does this mean? Okay, so this means that, so since the value of m is equal to 1, this means that the reaction is first order with respect to CH3, CH, Cl, CH3. So you need to make sure that you write this. Okay, this is very important. If you just leave the answer as m equals to 1, it is not complete. Okay, meaning I don't know m equals to 1 is for which reactant. We have 2 reactants here, so you need to clearly state here. It's first order with respect to whom. Okay, so the same step we will use to find what is the value of n here. Okay, so to find the value of n, so check again on the data. Okay, we will need to constant the concentration of CH3, CH, Cl, CH3, the first reactant. So the one that has the same concentration is this two. Okay, experiment 1 and experiment 2. So we will compare between experiment 2 over experiment 1 because the rate of reaction for experiment 2 is bigger. So let's write down the comparison. So let me show you the same step. Let's do it together. So experiment 2, the rate is 6 times 10 to the power of negative 3. So basically we just take this value, okay, equals to K, concentration 0.15 to the power of m times 0.50 to the power of n. Okay, so please do it one by one so that you won't get it mixed up. Okay, because it is very easy for students to make silly mistake getting the values the concentration, the rate mixed up. Okay, so for experiment 1 is 3 times 10 to the power of negative 3 K, 0.15 to the power of M, and 0.25 to the power of N. Okay, even though we already have the value of M here, you don't have to substitute here, because what we'll do is the same as we did for the first one. We will cancel the same term. Okay, like this. Just leaving us with despite to be calculated and also despite. So from here, what we will get is, so we will get here 2 equals to 2 to the power of N. Okay, since the base is the same, it's 2, meaning it's 2 to the power of 1 equals to 2 to the power of N. So we can conclude that here that N equals to 1. So the same thing, you need to write down the statement. The reaction is first order with respect to sodium hydroxide. Now, settle with question part A. So let's move on with question part B. So part B, the question asks, write the rate law for the reaction. So this is the rate law that we write initially with the order of reaction as M and also N. So for B, you will write down the rate law with the correct order of reaction that we have calculated. So B will be written like this. So for question C, the question asks for the overall order of the reaction. So to find the overall order of reaction, we need to add all the order of reactions of all the reactants. So we're going to do it like this. So C, since M equals to 1 and then N also equals to 1, so the overall order of reaction is 1 plus 1 equals to 2. Okay. So we make a conclusion here that the overall order of reaction is second order. Okay, so is it necessary for you to write this statement? Not necessary. Okay, but provided you must write this part. Okay, you must have the complete title, overall order of reaction, and then the answer. Okay, and you need to put okay, overall order of reaction equals to 2. Okay, second order, like that. Okay, so the last part of the question, part D, the question asks us to determine the rate constant for the reaction. Meaning, the rate constant, we want to find what is the value of K. So to find the value of K, since we already have the value of M and N, you can choose any experiment here to find the value of K. So just substitute the value of M and also N. So let's say I want to use experiment 1. So D, from experiment 1, so the rate is 3 times 10 to the power of negative 3 equals to K, 0.15 to the power of 1 and 0.25 also to the power of 1. So rearrange the equation and find the value of K. So the value of K here is 0.08. and you need to make sure that you write down the correct unit. So, like we did before on the previous video, the unit of K will depends on what terms appear in the rate law. So for the rate, it's molar per minute, and this one is molar and molar. Okay, so it will be molar per minute over m squared. Okay, cancel. So the unit you will get as per molar per minute. So make sure you write down the correct unit here. So per molar per minute. So for rate constant, if you just write down this, just write down the answer without the unit, you will be not given any mark. You need to make sure that the unit is correct. Okay, so now let's proceed with example 2. So for example 2, determine the rate law and calculate the rate constant for the following reaction from the following data. So this is data that you have. We have 3 different experiments, experiment 1, 2 and 3, and 2 reactants here. So if you look at the structure of this question, the question itself is asked here. Okay, for example 1, it is divided into 4 different parts, but actually it's the same thing. Why? Because the question first asks to determine the rate law, meaning to find the rate law, we need to find the order of reaction first for each reactants, and then calculate the rate constant. How are we going to calculate the rate constant? From the rate law with the order of reaction respective to each concentration. So let's take a look now on the calculation. Okay, now, so let's start this question by writing down the rate law first. So from the balance equation, okay, our rate law will be, so rate equals to K concentration of NO2 to the power of M and concentration of CO to the power of N. So remember, the order of reaction is not from the balance equation, the stoichiometry of the balance equation. So we need to find that. Okay, now, the next part is we want to compare. Okay, so let's choose to find the value of M first. So to find the value of M, we need to constant the concentration of CO. So here, if you look here, concentration of CO is constant on experiment 1 and also experiment 2. So to find the value of M, we're going to compare experiment 1 and experiment 2. So since the rate of reaction for experiment 2 is bigger, okay, so it will be 2 over 1. So for experiment 2, let's write down. So the rate for experiment 2 is 8.4 times 10 to the power of negative 3. Okay, equals to the concentration of NO as 0. First we must have our K. K concentration 0.1 to the power of M, and then carbon monoxide also 0. See, I mistakenly put here. So from experiment 2, the concentration of NO2 should be 0.2 and concentration of CO is 0.1 to the power of N. Okay, so next for experiment 1, the rate is 2.1 times 10 to the power of negative 3. Okay, and then K concentration of NO2 is 0.1 to the power of M. Concentration of CO is 0.1 to the power of N. So cancel the term that is same. So cancel K and cancel this term. So from here, straight away calculate. So you will get the value here 4 equals to 2 to the power of m. So if you look now, the base is not the same. So to find the value of m, you need to make sure that the base is the same. Okay, so it will be 2 to the power of 2 equals to 2 to the power of m. So from here, the value of m is equals to 2. And write down the statement. The reaction is second order with respect to NO2. Okay, so settle for NO2, settle for the value of m. So right now we want to find next is for the value of n. So to find the value of n, we need to constant the concentration of NO2 here. So let's take a look at our data. So which experiment has constant concentration of NO2? So it will be experiment 2 and experiment 3. Okay, so since experiment 2 has a bigger rate, so it will be experiment 2 over experiment 3. Or you can do it the other way around. So let's say I want to do experiment 3 over experiment 2. Okay, so let's take a look. So experiment 3, the rate will be 8.3 times 10 to the power of negative 3 equals to K 0.2 to the power of m and 0.2 to the power of n. Next is for experiment 2 is 8.4 times 10 to the power of 3 over K 0.2 to the power of m and 0.1 to the power of n. Okay, so the same step, cancel the same term K and also concentration of NO2. So from here, you will get the value as 1 equals to 2 to the power of m. So once you get something, once you get the number 1 here, okay, like I said before, we need to make sure that the base is the same. So 2 to the power of what will give you 1? So it will be 2 to the power of 0 equals to 2 to the power of, sorry, this is not m, it should be n. Okay, so with that we can conclude that n is equal to 0. The reaction is zero order with respect to CO. Okay, so how are we going to write this inside the rate law? Okay, so let's take a look here on the left hand side, since I still have some space here. So you're going to write down the rate law as rate equals to K concentration of NO2. So we get its second order to the power of 2 and CO to the power of 0. So you know anything to the power of 0 is equals to 1. So that's why you don't have to write down. So just leave CO. Can we leave CO out? Yes, of course, because it's to the power of 0, meaning the concentration of carbon monoxide has no effect on the rate of reaction. The rate of reaction will only change when we change the concentration of NO2. Okay, so now the next part of the question is to find the rate constant. So to find the rate constant, the value of rate constant, you can choose any experiment. So I want to choose experiment 1. So I write it down here. So from experiment 1, okay, I just substitute all the values. So experiment 1, 2.1 times 10 to the power of negative 3 equals to K 0.1 to the power of 2. Must I put carbon monoxide? No need. Why? Because it is not inside the rate law. Okay, so from here, find the value of K. So K equals to 0.21 per molar, per second. And if let's say you want to put the value of CO, yes, you can do that. Just make sure that you put the correct order of reaction. Okay, it's to the power of 0. But since you know it's 1, so you don't have to put it. Okay, so that's all for our initial rate method. So I provide you with some questions, so try to do them, and if you have any problem, do directly ask me, okay? So for the next video, I will continue with the method to determine order of reaction. We're going to look on half-life method and also linear graph method. So from the previous video, some of you asked me about how do I get the half-life. For example, 2, if I'm not mistaken, how do I get the first half-life is equal to the second half-life? Okay, how do I determine that? So I will explain that on the next video, which is on the half-life method. Okay, so for the half-life method, please make sure that you prepare a graph paper, because we need to sketch a graph, and it's not sketching graph, you need to plot a graph, so you must have graph paper. Okay, so that's all for this video. Thank you.